So welcome to the first presentation of this PUG. Just a few words to me. I'm Robert. I'm done 25 years experience in Progress, mainly the last 20 years in web development, and a lot of people know me as a Node.js guy because I'm working with Node.js more than 10 years. In the web world, so at the moment, if you're doing applications, you have the choice of 3 different frameworks. So normally it's Angular, it's Vue, it's React. There are a few others like Svelte and so on. But if you want to have complex applications, then you have to go with one of these 3. For me, I decided to go with Vue a few years ago. I've not done any project with React. I've done a lot of projects with Angular. But Vue, as I've learned it, is really amazing, especially for complex applications. A lot of people say for complex applications use Angular. Vue is only for simple ones. My opinion, because I've done complex applications with Vue, is completely the other side. So I'm going with Vue. In Vue, or with Vue, there are, again, the decision between 3 frameworks. Without a framework, starting only with a native Vue, it's possible, yes, but it makes a lot more fun if you're doing it with a framework. There's Nuxt. Nuxt is especially for server-side rendering. So if you do server-side rendering and just want to do this, perfect. Vuetify and Quasar. I'm going with Quasar. I tested all of the 3, but for me, Quasar has been the one which is really amazing. And today I want to show you why. So in the internet, there are, on one hand, very good documentation on the Quasar site itself. And on the other side, you do have a lot of tutorials and things in YouTube and Quasar Awesome and so on. So if you go there in the internet and search a little bit, you get really huge information and very good tutorials as well. So why Quasar, or what can you do with Quasar? At the end, and this is what I want to show in a very simple demo later on, you have one side, the web application. Web application just inside the browser. There you have the choice, and most of the time you're doing SPA, single page application. So the difference to a normal website is a website, you get HTML, you render it, you have a navigation there. So if you click on a link, complete site will be reloaded. And this is what you don't want to have in a complex application. In a complex application, you just load one page, and then your business logic is coming in mind, and the business logic is rendering, is changing. But at the end, you want to have a state management, you want to have cached data inside, which should not be reloaded. So you want to act with them because of the complex application. And this is why most of the time you're going with SPA. The progressive web app is a little bit in contradiction to it. It's like a single page application, but there's a background task running, and normally you should only communicate to the backend via this background task. Why? Because in a progressive web application, you can't manage it that you can go completely offline. So there you would cache your data, there you would, but you have to write your own synchronization inside, but then you're able to have a complete offsite or offline application, where when it's going online again, you have to synchronize your data, but people are able to work with. It's not that easy. That's the reason why not so many developments are outside with a progressive web application, but that's the difference between it. With Quasar, you can do both, and you can do server-side rendering as well. Server-side rendering you normally use for enhancing speed, because the browser then has not to render so much HTML, so the server is doing it for you. But there's a contra as well. The contra is if you want to have the server to render your HTML, and you have a complex application, you have data. The server has to know the state of your data, so you have to transfer the data to the server as well. So that's the reason why server-side rendering is more in the direction where you're working with websites, not with complex applications. There's a second one for mobile apps, and the fun part is we will show later on that, especially for mobile app, you use exactly the same development you have done for the browser. Just telling it, okay, now put it on a mobile app, and you can run it as an app on the mobile phone. If there are some people who have experience inside, that there have been Ionic years ago. Ionic has been quite bad from performance side. So meanwhile, this Cordova and Capacitor, they're nearly the same speed than a native app, because the WebKit engines inside of the modern mobile phones are so good and so optimized for browser rendering that they do nearly have the same speed. So there's no really reason to go native on a mobile phone because of performance. There is another one, multi-platform desktop app. This is normally done by Electron. Electron is a Node.js engine we'll see later on, so that you take your development, your application, compile it as an executable, so that you can install it on a PC or on a Mac, Linux system, whatever. This is especially because normally when you're in a web browser, you have a sandboxed system, which means you're able to have an application, but you're not able to communicate with the system, with the operating system. If you need directly information from the printer, or you need a direct interface to a telephone system or whatever, it's difficult to come out of the sandbox. But with this Electron engine, you are able to. We will see this later on in the demo. There's a fourth one, which I don't show, but tell you a little bit about it, browser extension. Browser extension means that you can enhance the browser a little bit. And this means that, for example, you have a background script which is non-DOM. And from this background script, you have an event bridge. And from this event bridge, you're able to speak or communicate with the different tabs inside. Especially in Chrome and Firefox, it works very well. The other browsers, it's bit tricky and a bit difficult, but for Chrome and Firefox, it works really cool. As an example, one of my largest projects I have at the moment is a system for ambulance. And in the control center of an ambulance, they normally have 4, 5, 6 monitors. So each employee who does this position there has a lot of monitors and opened windows. And we have to communicate, the different windows have to communicate with each other. And to minimize the traffic to the backend, we have one main window, and from this main window, we use a browser extension to do the communication to the others, to synchronize them. So in this case, it's very easy to know the state of all of the windows and to actualize the data in there. So that's browser extension in fast, which could be done with Quasar directly out of the box as well. Let's go a little bit inside of Vue. A normal Vue file is structured like this. So you have a template on one hand where you have your HTML. So here you put in your HTML code to visualize things. You have in the middle a script tag where you put your business logic inside. And at the bottom you have styles where you can have style sheets inside. You can classes, you can have scoped classes so that this class is only available inside of this script. And there's meanwhile a second, and the difference between is just that here the script has a setup attribute inside. And as you can see, there is no more necessary to define component to export deep. So this is all done automatically. Normally you have a setup routine, and this setup routine is your business logic in. And at the end of this setup routine, you return your data. So you return the variables you need inside of the HTML or things. And this is not necessary anymore in the modern view. So you just put in here your business logic. And inside each variable you define, each function you define is automatically available in the whole environment. So you can use it in the HTML part on top. We will see this in a minute. The installation is very easy. On one hand, that's why I love it, because you first have to install Node.js. After Node.js is installed on your system, you do just an npm install. -g means it's global, so that the command line interface for Quasar is available globally on the system. And then npm init Quasar from the directory you're starting off. What it does, it automatically asks you a few questions and uses the name of the project as the subdirectory from where you are, creates a subdirectory inside, and then you have the structure. You have to go to this subdirectory then and just open Quasar dev, and then you're automatically in development. There's a webpack or wheat, depends on how you did answer the question on the init Quasar before, and then the system automatically watches what you're doing, and as soon as you make any change in the system, it automatically recompiles, and you can see it directly online. And this is the first simple demo what I want to show you. I prepared a very small program, and this is what we have here. Each program, or this Quasar init does create a source directory, and inside of the source directory you already get a structure, and mainly at the beginning it's, for example, this app.view, and this Okay, and this app.view should better? Okay. Has nothing else than the router view inside, which means it does not render anything. It just uses the router. And if you look inside the router directory here, there's a routes TS, and this is at the moment the static routes. You can have a dynamic as well, as I have in my system. So first of all, it starts layouts main layout, and inside there we have pages index or cust edit with a path customer. So let's have a look inside the main layout. The main layout is a bit more complex now. So we have a header, we have a drawer, and we have a container, and inside of the container again we have a router view. How does it look like? So if I start Quasar dev at the bottom, let's make it a little bit. Is it readable so? Or so if I start Quasar dev, then it tells me at which address this local development is available now. So I'm using localhost 9000, so one of them, and here we are. So we have our header on top, we have our drawer, which we can put inside, outside. In the middle we have just a text, PUG Vienna, because this is the index page, and the index page does not have nothing else than this text. And we have a cust edit, and this cust edit now is our business logic for a first program. So now if I go to this customer, then you see here the the route is changed to customer, and then we are going inside here. Hopefully we have, no, we don't have at the moment. Yeah. No. Is there a PUG challenge? Ah, here is, yeah. Speaker, but for speaker I think we need the password. Does anybody know the password for it? Bitte? Okay, dann nehmen wir das andere. Wahrscheinlich das gleiche sein, aber das andere ist? Vienna?
Vienna mit großem V.
Vienna on site. So Vienna with big V.
Yeah.
And on site with big O and 2022 and then hashtag.
Let's see if we get. Looks like okay. Thank you. Works. So maybe you know the data a little bit, so found this database somewhere in the internet. It has the name Sports 2000 or something like this. There's the REST interface from Mike Fechner from his Smart Component library running at the end, so I get the data directly out of a Progress database in this case. It's a very, very simple table I have here. And inside of this business entity, I just get these 4 fields. When I click on it, I go to the server again and get the complete record with so the business entity of this. So down here we have, if I make it a big, then we have 3 columns. It reduces to 2 columns depending on the size of the window. So this is just done inside, and this is the typical thing you can do with all frameworks, with React, with whatever. So in Quasar it's working like this, that you tell the system, okay, if it's very small, take the whole. If on small, take the whole as well for the first line, but for the others, take 50%. And if it's large, then make 30% for each of the columns. So then it's automatically resizing and rearranging. But it's, yeah, not a big deal at the end. The data at the end is coming out from a state management. Here I'm using the state management, and the state management, to use it, is very, very important. Why? Because it minimizes rendering. It's always the same for each JavaScript framework. If you're going mobile, if you're going JavaScript itself is extremely fast. What is time consuming at the end is rendering HTML. The render process is the one which takes a lot more time than running any JavaScript commands. And this is why I love Vue, because what Vue does in the background is emulating the complete DOM. So everything which is rendered, what you see, is emulated in the end with a virtual DOM. And at the moment I'm going inside and changing anything in this, changing any data, what it does is first, in the virtual DOM, emulating what should be done, and then comparing with the DOM itself and saying, the only thing we have to change is this div. So the rest stays the same even if we change the complete data. So it minimizes the rendering. And this is done in an extremely efficient way, so that even complex applications are extremely fast. When we are going inside the state management, then we can see when we're going to the development tools. Inside of the development tools of Vue, you have the complete structure of the application. So you can go to each level of this. So we can go inside the main layout, see what is inside, which variables are defined, which is the state of the variable and others. If we go to, for example, the cast edit, then we can see, okay, there are 4 columns. This is the columns for the table on top. So you have the first column, which is aligned right, field ID. So we can see the whole structure. We can see what happens inside. So if we want to debug something or look for an error or whatever, it's really amazing what you can do with this development tools they have done there. And this is what I love, especially from Vue. The state management is here as well. So we have customer state. And inside of this customer state, we have the list. This is for the table on top. And we have the record. No? This is the data for the record we are showing on the bottom. As soon as we click somewhere else, then it automatically changes. Now we have the other one inside. And we can see exactly what happened. The routes, the timeline, and different other things. Before changing a few things to see what happens if we change inside of the program, I think best would be if we go to the next part. So for web, okay. Now, if I have this application, very simple, very small, very straight, and I want to have it on a mobile phone, then inside of the directory, I just go inside, say, okay, Quasar mode add capacitor. As seen in a few slides before, capacitor is one of the engines we can use for the mobile development. And then everything we need for mobile development is installed now. We again start Quasar dev, but this time we tell the system, okay, in the mode capacitor, so it's not rendering or doing for the web browser in this case, but uses the capacitor mode, and as a target, I can put inside now iOS or Android. In my case, I'm trying with iOS, and okay, here we are. And so if we stop it, -m -t iOS. So if we start it, what happens is that it automatically checks, because this you can only do in a Mac. That's important because of the restrictions of Apple. It checks for different enhancements, ports for an Apple environment and this stuff. Then it automatically starts Xcode, which is the development or the only development you have for iOS. Then here, for an emulator, I can, for example, go inside and tell, okay, let's take in iPhone 12 and start it. And then it builds the application. So it first starts, here is the emulator. So it starts the emulator, builds the application, runs the application in this emulator. I could do it in my mobile phone directly as well if I have a USB connection. So you can test it in real directly on a mobile as well. First in an emulator, we can test it on an iPad, whatever you want. Same for Android. And here we have it. Yeah. So if we go inside, then we should get exactly the same data. And so this works like it has before. I can scroll.
Change the data in
I can change the data as well, yeah. If I change anything inside of the program itself, let's go to the editor. Let's take the main layout, for example, and where is this Quasar app? And if I change it, then it's directly inside of the application. So the development, especially of mobile, is very fast as well. So you get it in nearly real time. This is the old CPU, so with the new one it's much better. You really get it nearly in real time in the application. You can test it, can change it, and can work with it. So at the end, it's exactly the same business logic than you have before on the website. The only thing which happened is, due to this add mode capacitor, we have a new directory, source capacitor. In this source directory, we have, for example, here iOS app, and here we have different change enhancements inside. So if you need, for example, now, let's say you want to use a camera, then you just install the module for the camera inside of the source capacitor, and you're able to use the camera as well. So you can use the native system environment from the devices as well, directly in the system. The fun thing is that inside of the program itself, from Quasar, there is an platform object, and with this platform object, you can even inside of the application check, I'm running now in a web browser, I'm now compiled, I'm on which iOS, on which device I'm running. Is it iOS, is it Android, which resolution does it have? So you can react directly at these parameters as well. Or if you want to have going down to the system, then you can go directly in this source capacitor directory and enhance it, the application inside here, with your native things. So we have done, for example, an application with it for ambulance, where we get real-time data out of it. We get an event-based geolocation, so that we have a Google Maps where we can see each ambulance driving around, so that the people this position do know exactly where they are and what happens with it. So to make it a bit faster, we are going directly to the Electron part, and then we are doing a few small changes so that you can see what happens. The Electron part is nearly the same. So at the end, again, you're going Quasar mode add Electron in this case, and just Quasar def minus m electrons, also we are compiling it in the mode of Electron. Electron is an executable then. So what happens with Electron at the end is, with the local user rights, a Node.js engine will be started from the system. It's the main process. The main process starts a renderer, and inside there we have the application. So the application itself is still in a WebKit, is still sandboxed. So from the application itself, we are not able to go down to the operating system. But between the main process and the renderer process, there are IPC requests and responses. And that's where we can go inside, say, okay, if we need something from the operating system, like printer or print directly something inside which would be not allowed from WebKit, we can put from there. Do an IPC request to the main process. There is a normal node instance running, and this normal node instance I can enhance with whatever I want. Libraries from Node.js, whatever we are doing here, and from there I can go directly to the operating system. So this is not sandboxed, WebKit is. So again here, small demo. So minus M electron. Now it automatically compiles the app, and I have here a window which is running natively inside of. It's not a browser; it's a native application. Yeah, and again here, if I go inside, I have exactly the same application than before. The same functionality, but this is an executable now, running on the system. And this is the fun part, because normally you start with a web application, even if you want to have it installed later on your system. Because the layout, the front end, you're not changing. You can design the complete front end directly with normal web development, where you can develop very fast, and later on go to an executable or to a mobile app or whatever. Just a small thing, because of lack of time, but I think it's worth to look inside a little bit of the state management again. So inside of the state management, we have our routines, we have our structure to get, select, whatever. And the fun is that it automatically is reactive, and in Angular, for example, you have to work with observables, and it's really a mess to work with observables there. In Vue, it's all automized. So you don't have to care about when some data are changing if you work with the state management. Just as an example, in the main layout, if I go here inside saying, okay, instead of Vienna, I want to show if I have selected a record, I want to show the name of the customer. So record.name. So I put it just in the HTML, and in the cast edit, here I'm using the store. So I'm just taking this 3 lines, copy it here inside. I have to, because computed is not imported. What I'm doing here is just use the state management. I use the store. I open the store and I tell the system. I don't have to tell the computed. I could work with the customer store directly as well in this case. But just to show it for the moment, if I compile it, then we have here. And as soon as I'm changing the record, the name is all changed. So I don't have to care about, because I'm referencing to a specific field inside of the state management, and Vue does the rest for me. Even if, for example, if I go here inside and change it, yeah, it will change it the same, because when there is something, the change inside of this field value, the value will be reflected to the state management, and the state management tells the whole other system, if you are interested in this record, if there are anything else, just change it. And this is done in an extremely efficient way. And normally, you have all your things in the state management. You go to the server, get data or whatever from inside of the state management. And then you have just the front end, which is using the data, referencing to the data, and having some logic just for visualization, the business logic inside of the state management. Then it's completely separated, and you get the complexity of the applications directly out of it. Because if you're doing it exactly in this way, it's done automatically, you don't have to care. Maybe at last, we could go inside saying the platform. But yeah, we're still at the end of time. So if you're interested, then just ask me. I'm around for the next 2 days. I can show you a little bit about this as well. As an information for the other part, with add mode electron, there's, like with the capacitor, a new directory source electron. And here we have two files, main and preload. And as mentioned at the beginning, main process is the main process, running with the same user rights you have when you started the application. And inside there, you can go to operating system and so on. And with preload, you can enhance your system. I have a very small example. Yeah, this one, for example. This is for the ambulance stuff as well. So it's a very, very small Electron program where for security reasons, when there's a downtime of the internet, the customers are able to download a PDF file for the state of all disposition they have at the moment, and it will be downloaded every minute. So if the internet goes on offline, they have a PDF file for the rights for today. So they are not in Nirvana because they don't know where they should pick up patients at some of the hospitals or whatever. So then, and this is automatically downloading from the internet. And here is the main process. In this case, I have a IPC main handle download file. Here I am streaming, so I'm making a request, and from this request I get the PDF file, and I'm streaming it directly to the operating system without interacting anyone. Because I'm not in the sandbox here, the preload itself is just exposing main world. Download file is IPC renderer invoke download file. So here I'm invoking. And inside of the program itself, I'm just, no, it's not in program, it's in the downloader here. So in the downloader, that's the front end. In the front end, window.access API, because the preload has enhanced with the IPC renderer, the access API, create to world. So that's the reason why I have a window.access API object. And inside this, I'm directly able to call the function download I've defined there, which is doing the calling the IPC renderer, and then I can save the file in there. So this is how normally Electron is working from front end to the back end, and can do stuff for, or if you need something from the operating system, which is not sandboxed. So hopefully I could show you a little bit of why Quasar is, in my opinion, a very, very good system to develop for all of the different things, web, mobile, and executable applications. So any questions? It's normally a bad sign if there are no questions. I hope in this time it's a good sign. And I hope you did find it interesting a little bit. Okay. Thank you very much.